Here we have designed that if the number of inputs are 3, so we use 8 cross 1 multiplexer. If I ask you guys, can I design this circuit with the help of 4 cross 1 multiplexer?
Yes, doctor.
This time selection lines will be only 2. So how we can do this one? Because here is so. Listen.
Okay.
Listen. This time that was easy. And you just connect 8 minterms to 8 inputs, right? And you connect 3 to 3. So easy. But when I just make it half, 4 cross 1. So how you will choose which particular selection line must be there? S1 for S0, because you have 3. Getting confusion?
Yes, doctor.
Understand? Because we have only 2 selection line, but our inputs are 3 X, Y, Z. Understand? So there is it is so simple when you want to implement with the help of 8 cross 1. But if you want to implement half, yani 4 cross 1, it is 8, it is 4 cross 1. So how can we connect which particular input yani out of X, Y, Z, which I can connect there? So there is, but we can do it. And how can we do it? I am going to explain to you now. So yani, rather than choosing either input 0, 1, 0, 1, we decide any particular, input X, Y, or Z is gonna be the input. And 2 is gonna be for the selection line. See now. See this function. So same function, but the question is saying implement using 4 cross 1. When I am using 4 cross 1 multiplexer, it means I have only 2 selection lines. Understand? So what I will do, guys, I will write that X and Y is gonna be my selection line. So I connect it. Now, my output, because we have 8 minterms, but I have only 4 inputs. So I will find my inputs in terms of Z as a input. So Z is my input. So now guys, look here. XY0, XY0. Can you see? Both are 0, 0. Repeated. So when both are 0, 0, can you check what is the relation between F and Z? F is 0.
0. F is 0. When Z is 1, and Z is F is 1.
Okay, so can I say F is equal to Z?
Yes.
Yes.
Getting concept? Getting concept? Now, again, look here. X, Y value 0, 1, 0, 1. It is repeating again, guys. Yani if the combination 0, 1. Please check again the relation between them.
F equal complements it.
F equal.
MashaAllah. Complement? No. Why are you comparing? Because Z is as input. Z decided Z as input. X and Y is already decided. They are the value of selection lines.
Okay. So only looking at Z.
Understand?
Yes.
Only looking at Z, right? Now again, you can see X, Y line, they are repeating again. I can say 1, 0. Now you need to compare this with the... Now, tell me the relation. Simple.
F equal Y.
Y. Again, how can you compare with the Y? Your input is Z. You are comparing Z and F. Their relations. How can you bring Y? X and Y is connected to the selection line already. We decided to choose Z as an input. If the value of X and Y is 1, 0. What happening? Can't you say?
Okay, 0.
Can I say?
Yes, doctor.
F is 0 for both the possibility. Whether Z is 0, whether Z is 1, F is 0 all the time. Did you get it?
Yes, doctor.
Okay, look here. 1, 1.
F equal to 1.
F is equal to 1. Khalas. Easy? Clear now?
Doctor, just one question. In all
Yeah.
cases, we choose Z as
Okay.
input.
Yes. No, see, listen. We can choose any other also. Your question is very good. But choosing Z as an input is very easy. That's why if nothing is given, it's better for you to choose Z as an input. We can choose X as an input. We can choose Y as an input. But why I'm choosing Z as an input? The reason is you can see the value of these two is, same. Two lines, same, 0, 0, 0, 0. Another, 0, 1, 0, 1. Are you getting?
Yes.
Value of XY, I am telling here. Look here, 1, 0, 1, 0. 1, 1, 1, 1. So it's so easy to just, merge them together. This situation. That's why I am saying it's easy to consider this value because this is something here. Clear now?
Yes.
Okay, just let it finish first, then I'll explain to you. Just let me finish this question first. So now once we did this one, what is the next thing I have to do, guys?
Make a common.
Bus. See now what I did here now. Connect Z here. Connect Z complement here. Connect 0 here. Connect 1 here. So rather than connecting just min terms in the previous case, now our input is in term of Z. So this is Z complement, this is constant 0, this is constant 1. Now you can verify any particular, for example, this one, 101. So when you are saying 101, what is the value of selection line? 10. So when it is 10, which particular input is going to be connected to the F? 10. Is this that one? I2?
Yes.
And what is the value of I2?
0.
0?
Yes.
Okay, check here. 0 or not?
Yes, doctor.
Okay, this is the concept. Now, as per asking, teacher, is this always we need to choose Z? Now, I'm going to answer this one. If you choose, for example, which one you want to choose, X or Y? Tell me. I will give you the answer for that as an input.
X, doctor.
X. Okay.
Yes.
If you choose X as an input, guys, so you have to check where Y and Z value is repeating. So it is repeating 0, 0. Where is another value? Did you get?
Yes.
Yes, yes.
It means when these are 0, 0, either this case or this case, you have to compare now. So you will check here. F and X relation.
Equal.
Getting why? This one? No. See, in both the cases, F is 0.
Yes.
So you have to connect here 0. Second, this is 0, 1. Where is another 0, 1? Here. So these two rows you have to compare now. So you look here. This is 0. This is 1.
X complement.
This is 1. This is 0. Yani, what we are getting here?
X complement.
X complement. Very good. Similarly, 1, 0. 1, 0. Compare these two now. So this is 0. We have 1. This is 0. This is 1. Yani it is always constant value equal to 1. Very good. You are getting the point. This is 1, 1. This is 1 1. Please check again. This is 0.
Complement.
This is 0. No. Look again.
Equal.
This is 0. Equal. This is 0. This is 1. Yani f is equal to
X.
X.
This is 1. And now what is my inputs? Y and
Z.
sorry, selection line. LS selection line. Selection line is Y and Z and X as a input. Clear?
Yes. So Z is easier in this case.
That's why, yeah. But you can have anyone because you asked me, and that's why I replied to you. If you remember, guys, if you ask me, I can tell you more. But it depend upon your, because if you are not responding, how can I tell you more? You ask a question, I reply to you. But see, if nothing is given, which is gonna be your input, yani if it is depend upon you, so it is always easy. You choose this as a input because here you can see these rows are repeating. Similarly, 0 1 0 1.
Yes, doctor.
All clear to all of you.
Four.
4. So our truth table will be how many combinations possible?
16.
2's power 4 yani 16. So if I implement using 16 cross 1, so it's so easy. 1 2 3 4 5 6 7 8 9 16. Connect. But they are saying
8 to 1.
8 to 1 or 8 cross 1, right? So if this is the case, so yani I have to decide one as any one of the input. Now tell me which ABCD you want to use as an input, which is easier for you. D, very good. So we will choose D. And what about the ABC?
ABC will place
Selection lines.
selection line.
Okay, so it's so easy now. You can see. So this is repeating, right? ABC. These two values are repeating. So we will compare and we find that F is equal to D. Clear? So I will make I is equal to D. Similarly,
So D.
easy now.
Yes.
Yes.
This is the way. So this is question very important. You can have this type of questions, okay? Which you can make it like that. All right, guys. Good. So now, guys, this is about the multiplexers, and hope you understand. In order to implement any function with the help of multiplexer, we should know min terms. So these are all min terms. You can see. Then you can implement easily. All right. So, guys, one more interesting concept of the multiplexer. I want to design 8 to 1 multiplexer using dual. You know meaning of dual? Yani 2. 2 to 1 MUX and 1 2 to 1 MUX. How can we do this one? So what we want? We want 8 to 1. So our inputs will be 8. I am drawing all 8 inputs. I0 to I7. If we have 8 to 1 MUX, how many selections lines will be there, guys? 3. But what is with me? What I have? I have 4 to 1 MUX. Dual. Yani I have 2. Okay. So I will connect one upper, one lower. One upper, one lower. So if we have 2 to 1 MUX, so how many selections lines will be there? 2 only.
2.
Okay. So what I will do? I will make it common and I will connect to S1 and S2. One selection line is more required. So guys, still now how many outputs we will be getting from these two? 2 outputs. So I have one more 2 to 1 MUX, which I will connect here now. And this selection line will depend upon this one. Now guys, look here. If I say, for example, my selection line is 0 0. So what will happen at that time? I0 will be connected to I0 of lower MUX will be connected to I. Am I right, guys? Getting? So
Yes.
what you will be getting from the upper mux?
0.
I0. And from the lower mux?
I4.
I4. Okay. Finally, now, do you know if my selection line is 0, 0, 0, and if we are talking about 8 cross 1 multiplexer, what should be the value of y naught at that time? If 0, 0, 0 for 8 to 1 multiplexer, should it be I naught? Because if I say 0, 0, 0, so y should be I naught or not in case of 8 cross 1 multiplexer?
I not.
All right. So if I make it 0, so you will make it 0 here. So tell me which is the input going to be connected with the y? The lower I naught or I1?
I not.
This one? This
Yes.
one?
Yes.
So what you will be getting here? You will be getting y is equal to I naught, correct?
Correct.
Okay. So this is the very interesting concept. Yani, we are using here dual 2 to 1 multiplex, 4 to 1 multiplexer.
Doctor,
Sorry?
S2 equal to 1, it will be I4.
Definitely, yes.
Okay.
That's why I'm telling you. For example, if you just make it, for example, 1, 0, 0. So you know that what should be the value of y here? At this time, we will be getting I4. We know that one as per the concept of the mux. So see the logic, when you make it 1, so this line is going to be connected here. And this will block here. That will not go further. What will go? So this I here come, this will go here, then it will go here, and this is the connection. So I will be getting here Y4, I4.
So, Doctor, this is 2 to 1 multiplexer.
And 2 cross 1 mux. Yani with the help of dual this and one this, we can design a 2 1 mux. This is the question point.
So, 2 1 is needed.
Yani we are saying, for example, I don't have a 2 1 multiplexer in my, with me, but I have 4 to 1 multiplexer. I have 2 to 1 multiplexer, but I want to design large multiplexer. So I need 2 to 1 multiplexer and 4 to 1 multiplexer 2 and 1 2 to 1 multiplexer. Then I can design 8 to 1 multiplexer with the help of 2 to 1 multiplexer 2 and 1 2 to 1 multiplexer. Yani 4 to 1 dual and 2 to 1 single. We can design it. Yani we don't have the big one. I have the small one. So with the help of a small, I can design big. This is the question basically. Clear? Okay. And a concept is clear, right? So this is the just to tell you, we can do a lot of things, guys. We are not limited to something. We are here, we can do a lot of things here. That's why I'm explaining here. Okay. This is something. All right. So this is all about the multiplexer, guys. As I have multiplexer, the opposite operation is also possible, which is called demultiplexer. What it called? Yeah.
If it was 16 multiplexer,
Okay.
and I asked to do it with 4 to 1, I do 5 4 to 1, and then 1 to 2 to 1 multiplexer, right? So I need 5.
Why 5 to 2? Why 5 to 2?
To choose between the 4.
No, dear. Listen. Then in case, if you want to design 16 cross 1, correct?
Using 4.
Using 4.
4 to 1.
Okay.
Yes.
So 1, 2, 3. 1, 2, 3, 4. Yani 2 more will be here as per you. Yani, just a minute. If you want to design this one. So 1, 2, 3, 4. 1, 2, 3, 4. Right? Now, so 2 selection lines will be common. And
Yes.
if you have 16 cross 1, how many selections of line you required?
4.
4. Very good. So I am using 2 here. S0, S1. But I have still 2 more, which is S3, S4. But here I am using, so how many outputs I am getting here? 4.
4.
Am I right? 4. Okay. So what I will do here now, out of this 4,
4 to 1 multiplication, another 4.
another 4 to 1 multiplexer. Very good. You are getting, mashallah. Yani, this is the concept. We can do a lot of things this way.
Or instead we can do 3 to 3 multiplexer or 2 multiplexer of 2.
2 multiplexers. No, for 2 multiplexer, you need single yani, selection line. Then later on, you need one more selection line. This is clear first to you? This one is clear?
Yes.
Okay, I'm giving you that answer also.
Down and 1 for the final result.
See, this is also possible, as you said. So this is final output, but this one will be having common, and this will be connected to S3 all the time. Keep in mind, where S3 common, and this one the last one, yani sorry, S1, S2, this is S2, this is S3. So yani this is connected to S3, this is S2, this one is S1 and S0. Clear now?
Clear.
So multiplexer car has reached here. Now again we have to separate it. So demultiplexer always use at the receiver side, yani opposite operation now. So we have a single car, it can go here, 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 anywhere. So input is 1, output is multiple. So depending upon the selection line, this bridge will be moving out of 4 anywhere. So demultiplexer is basically this one. Yani single input, multiple output, and selection lines is there accordingly. So this is what 1 cross 4 multiplexer. Selections lines will always be 2 accordingly. So this this is I, by the way, keep in mind input. Input is connected to all the AND gates, but this will decide if I say 0, 0, so this I will be connected to Y not. So here, this is S1 and S0 is playing important role. If they are 0, 0, yani at that time, what will happen? This Y0 will be connected to I. This is not the 1. This is I. Can you understand this, what I'm saying?
Yes.
This is I, because now I could be 0, I could be 1. So that's why we are writing here I, yani connectivity with the I. Now, if this is 0, 1, it will connect to Y1. If this is connected to this will. So at a time, this I, yani input, will be connected to any output at a time, depending upon the selection line. Yani opposite operation of the multiplexer is the demultiplexer. So into you encoder decoder, we were using their 3 lines to turn on 8 bulb with the 8 switches. Remember? But now how many lines I am using here?
1.
Single, 1 only. So here is the advantage of the demultiplexer. You also reduce the more lines. But here is the one problem, or what you call one important thing, that the selection lines must be synchronized. Yani transmitter and receiver, they must know the value of selection line. For example, now I want to turn on the bulb 5. What I will give here? 1, 0, 1. Receiver will also know this thing. 1, 0, 1. So I will turn on this bulb. When I turn on, yani it will connect to this Y, and this signal will reach here. And for example, this is connected to, now when I say here 1, so 1 will go here, for example, high value, and this I is connected to 5. So high yani logic high. Logic high will make it glowing, and it will be receiving current, and this bulb will glow, except all will be off. So this is multiplexer and demultiplexer as a pair. Important is the selection lines must be synchronized. Yani MUX and DeMUX both will be knowing what should be the value of selection lines. That's it. Clear? To all of you?
Yeah, that's clear.
All right. So one question is, it's gonna be there. Keep in mind. Yeah, you have to be careful about. All right, guys. So it is very important. And like this. Now, guys, there is one, similarity between demultiplexer and decoder. So first, recall the decoder. This is the decoder, guys. You remember for the decoder, yani n input, 2's power n output. So we have 2 here. So output will be 4. So this is what? 2 to 4 line decoder, guys, with the enable. Enable is also there. Now, guys, look here, demultiplexer. In demultiplexer,
enable
we have,
should be there.
sorry?
Enable should be there as a standard in all.
No. Sometime is there, sometime not. Enable, you know that it should be 1 bus.
Yeah.
Yeah, but this is just to power. Yeah, it's not like any always. And this is decoder. Yeah, demultiplexer. I want to show you, what is the similarity between these two. See now. Can you compare their two tables for the demultiplexer? This is the selection lines and this is the output. And for this one, if you ignore the very first line, because here is what we are saying, if enable is 0, and you know that if you are not giving power, so there will be no output. Do you remember that concept? I told you earlier.
Yeah.
If E is 0, in order to operate this one, E has to be 1 all the time. So now below 4 lines, you look here when it is enable. So your input is 0, 0. Can you see the output now? Why
Yeah,
not?
it's the same.
It's not same, but one change is there, which I want to know. Check it again. Let's see who will tell. Compare these two tables and tell me, sir, what is the change here?
The change is A.
No. Okay, E, leave it. I already tell you, na E. Yani it should be there. Now you compare these 4 with these 4 rows. Down.
First one here is I.
I, very good. And what is here?
1.
1. Okay. If I make it 1 all the time.
Yes.
So here it will be 1. It will be 1 because I make it constant now.
Yes.
Did you get?
Yes, I get.
Okay. So now both tables are same or not?
Yes.
Yes.
It means is that if in a decoder I fix the input to 1, so this demultiplexer is equal to this decoder. Yani this selection line is basically working as this input, and that's it. You can see the table. They are very similar. Look like very similar. So this is the concept here in between encoder and decoder and demultiplexer. I make this I is equal to 1, so they are exactly working in the same concept. Yani I1, I2 is the selection, and see at a time here also you can see one output is high, one output is high. Same it's gonna be happen here if I just make it high all the time. So one output will be high. So they are saying that input of demultiplexer is equal to 1, so that demultiplexer can work as a decoder. Clear?